Hey everyone, we are now going to look at doing the quadratic formula where we're going to get complex solutions. So if you remember from what we've talked about in the past, complex solutions are solutions that have like the letter I in it. And we use the letter I to represent an imaginary number. Generally speaking, when you have something that's the square root of a negative, so let's say like we have the negative 16. Right? We would represent that as 4i, right? Because technically you can't take the square root of a negative number. And that hasn't changed, but we needed to come up with something so that we could give everything a solution using imaginary numbers, right? And so a complex solution is a solution that is going to involve an imaginary number and then is also going to usually be a sum or a difference with a real number. All right, that's usually what a complex number is. A complex number is, generally speaking, a combination of a real and an unreal or imaginary number. Right. So we're gonna go through a couple quadratic equations in this lesson. This lesson's pretty short, using the quadratic formula. We only got 2 problems we're gonna go through, but that's why the lesson's short, because they're a little involved. All right, so what we have here is we have our good friend, the quadratic formula, right? And we have it color-coded with the negative b and all that and everything. The A's, C is green, B is blue, right? Nice, cool, good stuff, man, right? So when we solve this equation, remember we have to have everything needs to be written as ax squared plus bx plus c equals 0, right? And this is our standard form of a quadratic, right? This is what we want our quadratic equations to always look like before we start throwing numbers around and getting all crazy with the substitution game, right? So when you look at this, you're like, okay, I got to move this negative 10 over. So that's the first thing you're going to do is you're going to take this guy and you're going to toss him over the fence to the other side. So you got x squared minus 6x. When you throw something over the equal sign, when you change sides, you change your sign. So it's negative here, it goes over the other side, it becomes positive. All right, so it becomes plus 10, and then you have your 0. All right, so now I'm going to do a little bit of color code magic here. So I'm going to use, try to use the same colors. So I'm going to start with my A's, right? And I'm going to say my A is equal to the number in front of the x, which is 1. My b is the number that's in front, or sorry, I said in front of the x, in front of the x squared. The a was the 1. Now the number in front of the x is my b, and that's negative 6. And then my number in front of c, and it's actually not in front of it, it is c, it's a constant, is 10. All right? And so I'm going to plug these numbers in to the quadratic formula. All right, so we're going to say x is equal to, and we're going to say negative, and then I'm going to do that, and then my b is negative 6. All right, we'll close that off, and then plus and minus. All right, let's use our square root, and then we're going to have negative 6 squared. Right, so we're going to have negative 6 squared, and then minus 4 times, well, my a is 1, right? And then c is 10. All right, this is really annoying, just so you guys know. All right, and then we cover this up. All right, and then we put our fraction line there, and then 2 times my a, and my a is 1. And that is enough of switching colors because I'll lose my mind. All right. So now let's start simplifying this. So we got x equals, well, you get double negative right here. So you got negative, negative. That always gives us a positive. So you go 6. And we have plus and minus. And we have the square roots. I'm going to leave that for a second. And we're going to do the bottom. We got 2 times 1, which gives me 2. Now, when I figure this out, right, what's going to happen is I'm going to square this first. So that's going to give me 36. And then minus, and then 4 times 1 is 4. And then 4 times 10 is 40. So I have 36 minus 40, all right, which gives me the lovely number negative 36. Or sorry, negative 36. It gives me negative 4. right? -4. Okay, so I can take the square root of 4, right? But we got to remember, what do we do when we have a negative? Well, when you get a negative, right, we're gonna take that negative sign out, and we're gonna think of this radical now as the square root of 4 times the square root of -1. And what we know about the square root of -1 is that this becomes I. This is what we use. The square root of -1 becomes I. That is our imaginary number. It's imaginary because you can't really do it, right? But that's what we're going to do with it, right? So now let me get you a little room here. So we have x is equal to 6 plus and minus. So this is going to give me 2 because the square root of 4 is 2. And then the square root of -1 is I. So it's going to give me 6 plus and minus 2I over 2. Right? And now I'm going to simplify this. So I'm going to go 6x equals, and I'm going to recognize that I can bust this up like this, 6 over 2, and then I'm going to go plus 2I over 2, and then I also have x is equal to 6 over 2 minus 2I over 2. All right, so let's simplify these. So 6 over 2 is 3, right? And 2 over 2 is 1. So I just get 3 plus I over here. And this one's going to work the same, right? You're going to get 3, because 6 divided by 2 is 3, minus I. So my solutions, right, are x equals 3 plus I and 3 minus I. Those are my complex solutions. And they're weird, and I get it, but that's how this works. Okay, so we're going to have one more video where we work one more problem for you. So good luck with this, but this is kind of the general idea, right? You're going to do this exactly how we've done it in the past. The only difference is now you're going to be pulling an I out. Okay, so figuratively here. All right, so we'll see you in the next one.